Hello everyone, today I will explain the reactance of capacitors and inductors. First, we'll start with the definition of a capacitor. A capacitor is the component of a circuit that stores electrical energy, and the formula of it is C equal Q over V, where C is the capacitance in farads and Q is the charge in coulombs and V is the voltage in volts. In a DC circuit, the capacitor becomes an open circuit, and the capacitor requires an AC current, and the symbol of it is shown below. And here we have the definition of an inductor. The inductor or coil is the component of a circuit that has the ability to generate electromotive force, and this is the formula of it, where L is the inductance in henries and U is the permeability and N is the number of turns, A is the area and L is the length. In a DC circuit, the inductor looks like a wire and has no effect. The inductor requires an AC current. As you see, this is the symbol of it. Format of a sinusoidal voltage or current. A sinusoidal voltage or current can be represented as a AM sine omega times t, where AM is the peak value of the waveform, t is the time, and omega is the angular velocity. Omega is equal to pi over t, t being the period of the wave. Lag between a current and a voltage, a waveform shifting to the left, is represented by AM sine omega t plus theta. A waveform shifting to the right is represented by AM sine omega t minus theta. On these graphs shown these types of lags. For an inductor, the current lags the voltage by pi over 2. XL equal omega times L is called the inductive reactance. For a capacitor, the voltage lags the current by pi over 2, and X equal 1 over omega times C is called the capacitive reactance. An example on reactance of a capacitor: let the voltage across a 2 microfarads capacitor be V equal to 100 sine 50 times t. The capacitive reactance is calculated to be Xc equal 1 over omega C, which gives us 10 power 4. The current equal V over Xc, which is equal 20 milliamp, and then finally we write them in a sinusoidal form. Finally, we have an example on reactance of an inductor. Let the current across 0.2 inductor be I equal 10 sine 50 times t minus 70. The inductive reactance is calculated to be XL equal omega times L, which gives 10. And the voltage is equal I times XC, which is equal 100 volt. And as we did before, we write it in a sinusoidal form.